This is Stargate Command. We are located in a decommissioned missile silo. For this reason, this is where we kept the Stargate. And this is it. It uses superconductors to create a stable wormhole that sends you to another planet. It was found in Giza more than 70 years ago, right before the Nazis took Egypt. When we first went through the gate, we encountered a race known as the Goa'uld, a race of parasitic creatures that also have great power. But today, we will not be studying them. We will be studying the gate, and see if we can improve on its design. Stargate was created by a race known as the Ancients, very intelligent and advanced race. It led to many cultures that now reside on Earth. They created it, but unfortunately they could not get rid of one problem. It is the byproduct of the wormhole. It is known as the unstable vortex. We are looking to eliminate it. But to do this, we must first figure out the rate at which the volume of the unstable vortex increases.
When the event horizon is forming, it creates a cylinder-like shape with a hemisphere top. This is known as the unstable vortex. The length of the vortex expands at a rate of 3.325 yards per second, and the radius expands at 0.45 yards per second. When the radius is at 1.15 yards, and the length of the cylinder is 3.35 yards, what is the rate of change of the volume of the unstable vortex caused by the event horizon?
First, you must define the equation and the terms necessary to complete it. The equation that we are going to use is volume equals pi times the radius squared times the length plus 2/3 times pi times radius cubed. R at this point in time equals 1.15, L equals 3.35 yards, dr dt equals 0.45 yards per second, and dl dt equals 3.325 yards per second. Now, we want to find dv dt. So, let's begin. First, we must take the derivative. So, when we take the derivative, we get dv dt equals 2 pi r times L times dr dt plus pi r squared times dl dt. And then for the hemisphere, it is plus 2 pi r squared times dr dt. Now we must insert the variables that we know. So we insert the radius, which is 1.15 yards. We insert the length, which is 3.35. And then we insert the rate of change of the radius, which is 0.45. And then for the second part, we do the same thing, but for the rate of change, we place in 3.35. And then we do the same thing for the last part.
Then simplify your terms. This will give us 3.4672 pi plus 4.397312 pi plus 1.19025 pi. All of that added together gives us 9.054812 times pi. So our final answer, which is the rate of change of the volume, is 28.4465 cubic yards per second.